Hello guys, welcome to continue our session. Today I'd like to discuss the continuity of any function. But when we discuss the continuity of any function, I have to discuss the domain or find the domain that you learned before in the previous year. Here, as I told you before, and as you will find in the important notes worksheet, which I uploaded already in on LMS, you have to open this sheet and remember all of the notes which I gave to you. Here, as you know, the domain of any polynomial function, sine, cosine, exponential function, all of these functions, their domain is all of the real numbers. Okay, but for the rational function like this one, like this shape of this function, or like this form of this function, as you see, is called the rational function. Rational function, its domain all real except the zeros of denominator. In this case, but you have to please revise worksheet important notes first before solve this part of the sheet number 6. For part A, what is the domain? Please focus. Domain of the function f of x is, here what is the zeros of denominator? Zeros of denominator when the denominator equals 0, when x equals 0. So the domain x not equal 0, because at x equals 0 in this function, the function it will be 1 over 0 undefined. The domain, because some of you asked me before, Miss, what is the meaning of domain? Some told me 1, 0, no, it is not value. It is a set of numbers such that the set of values of x such that when we substitute in the function defined. When we replace x by 0, it will be 1 over 0 undefined. That is why we said the domain of the given rational function x not equal 0. By another way, the domain of any rational function, all of the values of x except the zeros of denominator. Since the domain x not equal 0, this means f of x is continuous. Okay? On all real number. Okay? Except x equal what? 0. Understand? Because any function continuous on its entire domain. Since the domain x not equal 0, what does it mean x not equal 0? It means all of real number except x equals 0. Okay? Any other values of real number except 0. Understand? At x equal 0, it means the function undefined. So f of x has here non-removable what? Discontinuity. Okay, non-discontinuity. Clear or not clear? Why? We said non-removable if this function in the simplest form and we can't redefine this function. So we say this function non-removable discontinuity. By another way, this function when we find its limit, it will be does not exist and the function undefined at x equals 0. I can redefine because it is in the simplest form. If the function undefined or the limit does not exist or it has unbounded behavior at this value of x, it will be non-removable. Please revise the sheet which I uploaded. All of this already is written in it. Understand? So I have to define the domain to discuss the continuity. According to this one, I can discuss the continuity because any function continuous on its entire domain. By the same way, look for part B. Part B. This function is rational. Domain of g of x is all of real except the zeros of denominator, because that is the definition of the domain of any rational function. I have to accept the values of x which make the denominator equal 0. X not equal what? 1. That is my domain. It means all real except this one. Otherwise, the function other than this value of x, the function defined at it. Okay? Here, g of x is continuous. Continuous on all real number, okay, except x equal what? 1. Because the function undefined at x equal 1 and all of the function continuous on its entire domain. Okay? X equal what? 1. At x equal 1, g of x has discontinuity. But what is the kind of this discontinuity? If the function can be redefined, okay, in this case, removable. In this case, as you see, we can write x minus 1 multiply x plus 1, okay, over x minus 1. I can redefine this function, so x removable, not non-removable. In this case, I can't redefine. I can redefine the function or simplify it. Gx is, has removable what? Discontinuity. At what? At x equal 1. Have you understood, please? I'll show you this one here. I have to find the domain, as I told you, of any rational function that you learned before. X not equal the zeros of denominator. Gx is continuous on all real number except the zeros of denominator. At x equal 1, the function has discontinuity. Why we wrote removable? Since we can redefine the function, so it will be removable discontinuity. All of this information, you can revise it well before solve this one. Please study the worksheet which has, I remind you by the domain and the type of that discontinuity in it. Okay? Here. In h of x, I have to discuss the continuity of this function, which piecewise function. I have to discuss its continuity on what? On the entire real number. Here, 0, the 0 is the value of x at which we have two different rules, at its right and its left. X less than, it will be x plus 1. X greater than e to power x. This function, continuous on all of these value of x, yes, because it is already continuous on all real number. No problem to be continuous on subset of a real number. This one, yes, I told me before, I wrote everything about the domain of natural exponential or exponential function, polynomial function. It is what? Continuous on all real, so it will be continuous on subset. Okay? What we have to discuss the continuity at number 0. I have to discuss the continuity. What is the condition? The function must be satisfied to be continuous at a point. Okay? I have to write what? Limit f of x. When x approaches 0 from left equal limit f of x. When x approaches 0 from right equal f of 0. That is the condition. Definition. That definition. Okay? Understand? So that is why I ask you, when we discuss the continuity, I have to write 3 steps. 3 steps. Find f of 0, limit f of x when x approaches to 0 from left, limit f of x when x approaches to 0 from right. F of 0, I have to replace in the rule at which we have equal. So it will be in the first rule, 0 plus 1, it will be 1. Limit from left, I have to replace in the rule at which x less than, because left, it means less. 0 plus 1, it will be 1. From right, I have to replace in the rule at which x more than 0, because right, it means more than. E to power 0, it will be 1. Since, as you show this condition, limit from left as the limit from right as the value of the function, so f of x continuous at 0 and all of the real number. Continuous here, continuous also. So f of x, or what? H, I'm sorry, h. I wrote here, I'm sorry, by mistake. I'm sorry, h, here h, here h. I'm sorry, because that is the given function h in part C. H of x is continuous. Okay, on all real numbers. Okay, clear or not clear? I think it's so easy. I think it's so easy. When we are talking about the continuity, we talk about the domain. For the last one, I think it's so easy. I have to discuss by this way, please. Here, for this problem, part D, domain, as I told you before, and I remind you before in worksheet important notes, domain of y here is all real number. So, since the domain all real number, the function in number D is continuous on all real numbers. Clear or not clear? The skills I need during this lesson, I have to remember the domain of some function, like rational function, how to find its domain. All of x not equal the zeros of denominator. Okay? Please don't forget. I hope you understand everything here. Let's discuss the second question. Question 4, 5, okay? Yes. Focus with me. I hope you understand. Here, he asks you, determine the interval. Interval, it means, do you know what is the meaning of interval? At which the function is continuous. Any set on the number line, before I begin to solve, try to remember. Any set on the number line can be represented by using what? Interval. Please focus. Here 1, 3, 6. As you know, here we have an infinite number between 1 and 3. Okay? So we use interval. How to represent all of these numbers here between 1 and 3? If 1 included and 3 included in my set. Look here. This bracket, I use it. It means closed bracket. Closed bracket. Okay? 1, 3. I have an infinite number between 0 and 3. Since this means 1 included in my set, 3 included in my set. If we use this closed bracket, that is the shape of this bracket. Okay, if we use, look here, like 8, for example, 6 and 8. Look here, if you have like this one, this is open at 6, this means 6 not included, that is open, not included in my solution or in my set. It means all of the sets more than 6 and less than or equal 8. That is mean 8 in my solution. All of these number greater than 6 and equal 8. Until what? 8. 8 included. If we write like this one, for example, 4. Here I write 4, 6. It means 4 not included, 6 not included. How to represent sets of number or group of number on the number line using interval. This is called the interval. That is open interval. Okay? That is what? Closed interval. I remind you by something that you learned before. How to express set of number on the number line. This means x not in my set. All of the number here. Understand? 4 and 6, it will be the number between 4 and 6. This means 4 not included, 6 not included. Understand? Okay. Please be careful. As you know, this one, if you expand this one and multiply, distribute, it will be also polynomial product. This polynomial, it will be polynomial also. So, as you know, the domain of this function or real number. Here, what is the domain of this function or real? You have to tell me what is the domain of this function or real number. Understand or no? Here, since it's the domain or real number, this function continuous on all of real number. How to express real number? By using the number line. Here, negative infinity and infinity. It means all of the real number from negative infinity to infinity. So, this function f of x is continuous. Continuous on what is the, how to express this one by using interval? Negative infinity, but it must be open, and infinity must be